This is lesson 1-5, scatter plot. A scatter plot is a graph that relates two groups of data. So let's look at making a scatter plot. The table below shows the number of hours worked and the amount of money each person earned. Make a scatter plot of the data. So they want us to make a scatter plot, which is simply a graph that relates two groups of data. But when I look at this table, I notice I don't have two groups, but I have 1, 2, 3 groups. So I have to determine which two groups are the two that I'm putting on my scatter plot. So again, I'll look back at my problem. The table below shows the number of hours worked and the amount of money each person earned. So those are the two things I care about, the number of hours worked and the amount earned. It doesn't say anything about the names. We don't really care about the names. We're not putting those on our graph. So I'm going to completely ignore those. Now, these are the two we're putting on our graph, but before we can graph, we need to go over a little review of what is a graph. So remember the graph is a coordinate plane made up of two axes, anyway, here's what a coordinate grid looks like. Remember that this is your x-axis and your y-axis. Also that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now within quadrant 1, our x is always going to be positive because remember this is your origin. So if you go to the right of 0, it's positive, and your y is also positive. You go up, it's positive. In the second quadrant, for x, you're going to the left of 0, so that's negative. Y is still above 0, which is positive. In the third quadrant, to the left of 0, negative, and we're going down now, so negative for y as well. And in the fourth quadrant, we're going to the right, which is positive for x, but down for y, which is negative. Now, looking at these quadrants and comparing our numbers, we see that all we have are positive numbers. So in which quadrant are all of our coordinates going to be? Well, we're going to be in the first quadrant. So really, do we need the second, third, or the fourth quadrant? Not really. So when I go to graph, I'm simply going to graph the first quadrant. So you see this is where the fourth quadrant would be, the second would be here, the third here, but we don't want to waste a bunch of space by making a big coordinate grid, so I'm really just concentrating on the first quadrant. Now in the first quadrant we have to figure out what goes where, what's on our x-axis, what's on our y-axis. So let's look back at our table. We have hours worked and amount earned. So how do we know which one is which? Well, it's really simple, really, because x is always first. So hours worked has to be x because it came first, and then y is, of course, next. But x is always first. So whatever your first column or first row is, that's your x. And then amount earned is your y. So let's go ahead and put that on there. Hours worked is our x. So x-axis is hours worked. And our y-axis was amount earned. So that's what I'll put on my y-axis. We have to let people know what these points mean. So we have to label our x and y axis so people know what it is that we're graphing. We also want to give them a title for our graph. So since we're talking about these are different students and the money that they're making, you could call it student earnings. You could also label it hours worked versus amount earned, or amount earned versus hours worked. Really, that part's up to you, but we just want it to be a good representation of what our graph is. Okay, so we want to start graphing. Let's look back at our numbers. I'm going to start with x. You always want to find out what's your smallest number and what's your largest number. So x is our smallest and y is our largest. Now, I don't know about you, but I don't really want to sit there and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until I get to 15. We don't need all of those numbers. So instead of counting by ones, I'm just going to count by twos to make my graph a little more concise. So I'm going to change my scale from counting by ones to counting by twos. 2, 4, 6, 8, 10, 12, 14, 16 is really as far as we need to go, but you can go ahead and write the next two if you want. 18, 20. Then as I look at my y's, again I want to find my smallest number and my largest number. And so again we see we certainly don't want to count by ones because we'd have to count up to 63. Even by twos, we'd have to have 32 splash marks, 2, 4, 6, 8 until we got all the way up to 64. So even that's too much. Fives would be all right. Fives would be just fine, or even tens. So I'm just going to count by tens for these numbers. So I have 10, 20, 30, 40, 50, 60, 70 is really as high as we can go. You can keep going if you want, but 70 is the highest number we need. Okay, now that we've come up with our scale, we can start graphing our points. And remember that a point or a coordinate is an x, y. So x coordinate, y coordinate, put those together and we come up with a point. This is an x, y point. So again, this is our x column, this is our y, so we just put together the first x and y. That's our first point. 6, 25, 50, 25.50. So that's our first point. So again, always graph x first. So over to 6, up 10, 20, 25, 50 would be about halfway between. There's our first point. 12, 51 is our next one. So we go over to 12 on the x-axis first, and up 10, 20, 30, 40, 51 would be right above it. Always x first, then y. Our third point would be 11, 46, 75. X first, then y. So over to 11, which would be right in between 10 and 12, and up to 10, 20, 30, 46, 75 would be right above the half. 9, 38, 25. 9, 38, 25. Over 9, at 10, 20, 38, 25 would almost be to 40. 15, 63, 75. So over to 15, halfway between 14 and 16, at 10, 20, 30, 40, 50, 63, 75 would be a little below halfway. And finally, 10, 42, 50. So over to 10, at 10, 20, 30, 42, 50, be a little above 40. And as we look at these points, we can definitely see a trend happening here. We see there is definitely a correlation between the hours you work and the amount you earn. The more hours you work, the more money you make. So since we see such a strong correlation, we can go ahead and draw a trend line for our correlation. So you want your trend line to just be, you want to go right through the middle of your point. So make sure you get most of your points on there or touching it. And in fact, I might move it just a smidge down here. We want it right through the middle of our point. So there's our trend line. And so looking at this, we can tell that there is definitely a positive correlation. When you see your points going up together, then that's called a positive correlation. If our points were going down, that would be a negative correlation. And we'll look at a no correlation in just a minute. So again, it's positive because as your hours worked increases, your amount earned increases, so they're both increasing, and it's a positive correlation. Let's look at one more. Use the data in the table below, make a scatter plot of newspaper circulation, and the number of households with television. So we have this another table. Again, they give us 3 pieces of information, but we really only care about 2. They want us to make a scatter plot of newspaper circulation and number of households with television. So those are the 2 data, 2 types of data, 2 groups of data that we're going to be focusing on. We are going to completely ignore the year. We don't care about that. So again, we've got to set up our chart, our scatter plot. And again, all we have is positive numbers, so we're going to be in the first quadrant. And remember, x always comes first. So this is our x, this is our y. X always comes first. So x is daily newspaper circulation in millions. So for x, daily newspaper circulation. And it is very important that we tell people that these numbers are in the millions. These are the millions. It's not 54, it's 54 million. And then households with TV is our y, again in millions. So y is households with TV, and again it's in the millions. All right, now we need a title for our graph, so you may say newspaper versus TV. And yours doesn't have to be this. It can really be whatever you want as long as it represents the graph and what the graph is about. So now that we've done that, we need to come up with scales for our numbers. So remember, look at your smallest, 54, and your largest, 62, and that'll help you come up with a scale. The first thing I noticed is my very smallest number is really nowhere near 0. 54 is pretty far away. So I could count by 2s, I could count by 5, but it's still going to be a while until I get to any numbers that really even mean anything. So, and then really 54 and 62 are so close together that I want to count by 1s for these, so here's what I'm going to do. We are going to skip a bunch of numbers. That's what this little zigzag says. It says I'm skipping a whole bunch of numbers, and then we're going to start at 52. 54, 56, you know what? And even I'm going to count by 1s. I don't even think we need to count by 2s. So instead of counting by 2s, let's count by 1s. 52, this would be 53, 54, 55, 56, 57, 58, 59, 60, 61, 62. So we had plenty of space to count by 1s. You can even go one more, 64. We don't need to go that far, but you certainly can. Now let's look at our y values. Our very lowest is 4, and our highest is 101. So as we look at these, we don't want to do any skipping because our lowest number is 4. But we also definitely don't want to count by 1s because 101 is our largest number and we'd be here all day. 5s even is really not enough to be counting by. So let's just go ahead and count by 10 so we can get all these numbers in there. So we have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and we should have made it one bigger, 110. Okay, so now that we have our labels, our title, and our scale for both our numbers, we're ready to graph. So our first coordinate, our first point is 54, 4. Remember that a point is an x and a y, x coordinate and a y coordinate. So 54, 4 is our first point. So over to 54 and up 4, 4 would be a little less than halfway. 59, 46. Over to 59, up to 46. So 59 is between 58 and 60, up 10, 20, 30, 40. 6 would be a little higher than halfway. 62, 59. Over to 62, up 10, 20, 30, 40, 59 would be right before 60. 62, 76. So over to 62 again. Oops, and that last dot we didn't put on 62. We needed to go one more over. So here's 62, 59. And this one we're doing now is 62, 76. So here's 62, there's 60, 76 would be a little more than halfway. 62, 92. So over to 62, here's 80, 92 would be right past 90. And the last one, 55, 101. So over to 55, right in the middle, up to 101. So 101 would be right past 100. So as we look at these dots, do you see any correlation in these points? I don't know about you, but I certainly don't. I couldn't draw a trend line through this. This dot's way up here. They're kind of just all over the place. So in this example, there is no correlation between your data. Now maybe if they had done the graph differently, like maybe if they had done the year and the daily newspaper circulation, or maybe year here and daily newspaper circulation, then maybe you would see a trend. You'd see that as the years progressed, people were getting less newspapers, 54, 59, 62 for a while, but then it went down to 55. Or really even, you'd probably see a better trend between the year and the households with TVs, because as the year progressed, certainly many more people had TVs. It increased every single year. The more years, the more TVs people had. Okay, but with this one, no correlation. Let's look at quick check 2. It says, in the graph, what does the data point 14,900 represent? 14,900. So I guess that's this one. It's right below 15,000, although it looks like it's on it, but it's right below it. So what does that represent? Well, 4 is your x. 14,900 is your y. So what is your x? Your x is age of car in years. So 4 would be the age of car in years, so it's a car that's 4 years old. A 4-year-old car. And then what does this other number represent? Well, Y is the asking price of the car in dollars. This is prices of mid-sized used cars. So obviously the older the car is, the less it's going to cost. So it's the asking price in dollars. So a 4-year-old car costs $14,900. And that makes sense. Again, we have a negative correlation here. The dots are going down. You see our trend line. The older the car is, the less money it's going to cost you. All right, let's look at just a couple more things. For instance, what if we wanted to just, not even from a graph, but from a simple sentence, determine, or a situation, determine if something was a positive, negative, or no correlation. So those are your choices. It's a positive, negative, or no correlation. So let me give you some situations. Let's say the amount of free time you have and the number of classes you take. So if you're going to figure out if it's positive, negative, or no correlation, you just need to first look at the second thing, the number of classes you take, and ask yourself, what happens as that increases? So the more classes I take, what happens to your free time? Your free time definitely decreases. So since they're going in opposite directions, that would be a no correlation. Oh, sorry, not no, but a negative correlation. They definitely correlate. One affects the other, but they affect each other in a negative way. One goes up, one goes down, so it's a negative correlation. Okay, let's try another one. The sales of snow shovels and the amount of snowfall. Again, you want to look at that second one, so the amount of snowfall. So as that increases, what happens to the other one? So if there's more snowfall, then there's definitely going to be more shovels sold. So since they're both going up, they're both increasing, that's a positive correlation. And let's look at one more. How about a high school sprinter's age and the time it takes to finish a 100-meter race. So again, we want to look at the second one. The more time it takes the person, does that mean that they're older? Does that mean that they're younger? No, these really have nothing to do with each other. Now, maybe if they had said, instead of age, maybe if they had said, like, length of legs. So the longer the person's legs, the less time it would take them. But really, there's no correlation between someone's age and how long it takes them to finish a race. So there's no correlation between those two things. And that's it for this lesson on scatter plots.